So homework day 26, just getting to understand some terms and the proper order. This expression here is what they call a polynomial. A polynomial just means that there are many terms, or at least more than one term. You have things that they call binomials that have two terms. Trinomials have 3 terms, and polynomials just mean many terms. So when you are putting your terms in the proper order, what you do is you rearrange it and you go from the highest exponent down. So if I were going to rearrange this expression and put it in the best order, I would start with the negative 8x to the 4th because it has the highest exponent. The next term would be the positive 20x to the 3rd. The next term, I don't have any x squared, so I go to the negative 5x. And then the constant term, the number without the variable, usually is always on the end of your expression. So that would be the best order for my expression. Coefficients. Coefficients are the numbers in front of each of your terms. So here my coefficient is negative 8, here it's 20, here it's negative 5. Nope. Here they want the leading coefficient. The leading one means it's the very first one you have on your term, and your polynomial. Well, the very first coefficient is the negative 8. The degree of your polynomial is just whatever the highest exponent is. This is a 4th degree polynomial because the highest exponent is a 4. So on number 2, if I were going to rearrange that polynomial so it's in the best order, which term would go first?
15b.
Nope. The negative 10v to the 8th, because that one has the highest exponent. So negative 10v to the 8th is the first one. The next one would be?
Plus 3v to the 4th.
Plus 3v to the 4th. Then we would have?
Plus 15v to the 2nd.
Plus 15v squared, and on the end?
Plus 20.
Plus 20. So that would be the best order for my polynomial. The leading coefficient then on that polynomial is?
Negative 10.
The negative 10, the very first number in front, negative 10. The degree of that polynomial?
8.
8. It's an 8th degree polynomial because that's my highest exponent. So on number 3, if I were going to rewrite that and put it in the best order, I would have?
Negative x to the 4th. Minus 10x to the 3rd. Minus 15x. Minus 18.
And so my leading coefficient would be?
Negative 1.
Negative 1. And my degree?
4.
Is 4. So again, just keep in mind that it's really a negative 1x to the 4th. If the number's not there, we know it's a 1. Sometimes they will switch these around and put degree first and leading coefficient second. Just pay attention that you put the proper one in the proper spot. Now, when you have a multivariate polynomial, which just means you've got more than one variable, you have to find the degree of each term by adding the exponents on the variable. So here, if I separate these into terms, the 5 is a term, the plus 2y is a term, the positive v to the 9th w to the 3rd is a term, and the negative 9w to the 9th y to the 5th v to the 4th is all one term. So your terms are separated by the plus or minus signs. A constant term that doesn't have any variables has a degree of 0 because there's no exponents on any variables. There's not any variables. Here, this term that just says 2y, that's a y to the 1st power, so it just has a degree of 1. Here I have to add. This is v to the 9th w to the 3rd, so the degree of that would be 9 plus 3, which would be 12. And then here I have w to the 9th, y to the 5th, and v to the 4th. If I add all those together, I get 18. So if I were to rewrite it, that term would go first, this one would go second, that one would go third, that one would go last. We really don't have to rewrite it to tell what the degree of the polynomial is. The degree is the highest one you get. So in this case, the 18 is going to be the degree of that polynomial. So on number 5, if I separate those by each of the terms, the degree of the first term is 9. The second one would be 8. The third one, 0. And the fourth one, 6. And so the degree of that polynomial is going to be 9 because 9 was the highest one we had. And number 6, if I divide that up into its terms, the degree of the first term is 9. The second one,
0.
the third one,
10.
10. And the fourth one, 9. And so my answer would be 10. Easy enough once you know what to do, right? The next ones we are adding and subtracting polynomials, and we sort of already did this, but now they just put parentheses around them. Before they just said combining like terms and quadratic expressions. But if I'm adding, obviously I'm just adding the like terms together. Oh, we didn't get any subtracting ones. We're going to make the last one a subtracting one when we get there. So you have an example of a subtracting one. But if I'm adding, I'm just adding the like terms together. And so I'm going to take the negative 7t squared plus the 2t squared. Negative 7 plus 2 would give me negative 5t squared then. And then I'm going to take the 3t plus the 4t, and I would get plus 7t. And then I'm going to take my negative 1 plus my 5 plus 4. So negative 5t squared plus 7t plus 4 is just going to be my answer when I add those two expressions together. And so again, if I look at number 8, there's a plus sign in the middle telling me I'm just going to add the like terms together. And so I would get
3y squared
3y squared
plus 7y
plus 7y. And that'd be it, because I'd get a 0 on the other one, and I don't need to put the plus 0, right? Number 9, I'm going to change that so you have a subtracting example. There, I now made it a minus. So when we subtract, we have to remember that when this negative is in front of the parentheses, we have to distribute that negative out. The first part's going to stay the same. It's just 4t squared plus 3t minus 7. But here I'm going to say, okay, a negative times a positive, it's going to make that a negative 2t squared. Negative times a positive, going to make that a minus 5t. And then a negative times a positive again, going to make that a minus 1. Technically, subtraction is adding the opposite. So we did the opposite of all of those signs in that second set of parentheses. What was that?
You just changed the sign.
I changed all these signs to the opposite sign, yep. And now I'm going to combine my like terms. So 4t squared minus 2t squared is 2t squared. 3t minus 5t, negative 2t, and negative 7 minus 1. Negative 8. So 2t squared minus 2t minus 8. And we'll get some more practice on the subtracting on the next ones, because those you're going to have both a sum and a difference in. They just made the problems a little bit longer. So, if there's a negative in front, we have to distribute the negative. If there's a positive in front, then we leave them alone. So here, first set of parentheses, just going to stay the same. W squared plus 6w plus 5. Here I have that negative. So negative times a positive makes that negative 9w squared. Negative times a positive makes that a negative 4w. Negative times a negative, going to change that to a plus 1. Last set has the plus sign in front, so that just stays positive 4w squared plus 5. So once I distribute out my negative, now I can combine my like terms. So 1 minus 9 plus 4, those are all my w squareds, right? 1 minus 9 plus 4 would give me
4W.
Negative 4w squared, yep. And then I look for my plain w's. I have a 6w minus a 4w, since the third term didn't have a plain w. 6w minus 4w would be
Plus 2W.
plus 2w. And then my constant terms, I have a 5 plus a 1 plus another 5, plus 11. So negative 4w squared plus 2w plus 11. Now on Alex, they're going to have you line them up a little straighter instead of hopping all over. So I'm going to rewrite this one the other way in case you like to do it that way. Again, the first one's going to stay the same. So 4y squared plus 5y plus 6. This one has a plus sign in front, so all of those will be the same. Negative 5y squared plus 9y minus 8. This one has the minus in front, so I've got to do the opposite of those. So what am I going to have? Positive
plus
8y squared and minus 7. And notice I'll put the minus 7 way on the end so that all their like terms line up nice and neat, since they didn't have any y's in the middle. And that way it's easier to see what goes together if you line them up that way. 4 minus 5 plus 8 would give me
-9.
no
7y squared.
7y squared. 4 minus 5 would be negative 1. Negative 1 plus 8 is a positive 7y squared. 5 plus 9
Plus 14y.
plus 14y,
Minus 9.
and then minus 9. 6 minus 8 minus 7 would be minus 9. So 7y squared plus 14y minus 9. The other thing to watch out for, and you probably know this by now, is when you've got that squared to make sure you hit the space bar or click down so all the stuff doesn't end up in the exponent. I see people doing that a lot, especially when they're in a hurry.
I didn't see how you're doing that. I just did it. I did it the first time.
Oh, that works too. Just giving you some options. So, number 12 here. Simplifying that, we're subtracting and adding, and so first one's going to stay the same. 2u squared minus 7u minus 4. The second one we have to do the opposite, so what are we going to have?
-5u minus 4u minus 6.
So minus 5u squared, a minus 4u, and a minus 6. Last one has the plus sign in front, so those stay the same. So we have a positive 3u squared, and then again they'll put the plus 1 with the constant terms. And so if we add those together, 2u squared minus 5u squared plus 3u squared,
U squared.
no, because u squared is 1u squared, right?
So it'd just be 0.
Is 0, so it's just gone, right? Cancels out. So if you get 0, you just leave it off. Negative 7u minus 4u.
Negative 11u.
Negative 11u, and then negative 4 minus 6 plus 1.
Minus 9.
Minus 9. So just negative 11u minus 9. (13, 14, and 15) we are now multiplying. And when you multiply here, you're using your distributive property. So you're taking the 9x to the 6 times the 8x and finding that answer. And then you're going to take the 9x to the 6 times the 7x squared and finding that answer, basically. So we said, oh, I got to take this times this and this times this. When we multiplied the front numbers together, added the exponents since our bases are the same. So 9 times 8, 72. x to the 6th times x to the 1st would be x to the 7th, 6 plus 1 more. That one had a plus sign in there. And so then 9 times 7, 63, x to the 6th times x squared, I add them, I get x to the 8th. These are not going to be like terms because they have different variables, and x to the 7th and an x to the 8th can't be added together, and so that's just what my answer is going to look like. So if I multiply my first ones together, a 10y squared times just a plain 9 would give me
90y squared.
90y squared. And then if I take my 10y squared times my negative 7y to the 4th, I would get
Negative 7y to the 6th.
exactly. 10 times negative 7 is negative 70, and I add my exponent, so 2 plus the 4 gives me y to the 6th. And again, they're not like terms. That's just going to be my weird looking answer. So number 15, if I use my distributive property, 5x to the 7th times 6x squared would give me 30x to the 9th. 7 plus 2 is 9. And then we have plus 5x to the 7th times 4x. 20x to the 8th, exactly. So 30x to the 9th plus 20x to the 8th. So 16, 17, and 18, same kind of thing. They just made it a little bit longer and a whole lot more variables in there. If I'm using my distributive property here, I'm going to multiply this times this and that times that. So 2c squared d to the 4th times negative 5c to the 6th d. 2 times negative 5 is negative 10. I add my exponents, so I have 2 plus 6 gives me c to the 8th. And then 4 plus 1 would be d to the 5th. And that would be my answer for my first term. Then I'm going to do the negative 4d to the 3rd times the negative 5c to the 6th. So negative 4 times negative 5, positive 20. Here I don't have any c's, but I do have the c to the 6th here, so I still have the c to the 6th. Then d to the 3rd times a plain d. 3 plus 1 is 4, so d to the 4th. So I got negative 10 c to the 8th d to the 5th plus 20 c to the 6th d to the 4th. And again, those are not like terms because my variables aren't exactly the same, so I can't really add or subtract those. I just have that crazy looking answer. So number 17, if I take the 8 a to the 6th b to the 4th times the negative 9 a b to the 5th, I would get
Negative 72.
negative 72,
Negative 7.
a to the 7th,
B to the 9th.
and b to the 9th, exactly. And then if I do the second one, negative 7a to the 3rd times negative 9ab to the 5th, I would get
63.
positive 63. Make sure you get the plus sign in there.
A to the 4th.
A to the 4th,
B to the 5th.
and the b to the 5th is still there. It doesn't disappear. 0 plus 5 is still 5 of them, right? So that's going to be my answer on that one. And so number 18 made it just a little bit longer. First term, negative 5b to the 6c times 6b to the 4th.
Negative 30.
Negative 30,
B to the 10th.
b to the 10th,
C.
c. Negative 30, b to the 10th, c. And on my middle term, negative 5b to the 6c times positive 3b to the 5th, c to the 3rd.
Negative 15.
Negative
B to the 11th.
15, b to the 11th,
C to the 4th.
c to the 4th, exactly. And then my last term, negative 5b to the 6c times negative 9c to the 3rd.
Plus 45.
Plus 45, b to the 6th,
C to the 4th.
and c to the 4th. So that big long thing all goes in for my answer. I got all that clicking to get out of my exponent. And if you're up on the exponent and just hit the space bar, you don't have to go down and click. It'll just move your cursor down. It's a little quicker to type it in that way. But all that goes in for my answer. All right. Not so bad, right? You can do those things.